Okay, so horns, hooves and hounds, mandibular morphometrics, and mammalian macroevolution through the Cenozoic. So morphometrics is a modern take on studying form and morphology. So form is highly informative. It can relate to function, ontogeny and phylogeny, and therefore morphometrics is an invaluable contemporary approach to this, using and providing quantitative data that can be statistically refuted or proved. And that's why we decided to apply geometric morphometrics to mammalian mandibles to test macroevolution during the Cenozoic. So you see, the Cenozoic has long been studied, and mammalian diversity through this period has long been studied because it relates to a big debate in paleontology between drivers of macroevolution. So is it external, sort of intrinsic environmental factors that drive macroevolutionary trends, or is it in fact biological interactions, intrinsic factors, red queen versus court jester, in fact? So there's been many traditional studies on this using taxonomic diversity, and we decided to apply morphometrics to get an alternative viewpoint, disparity perspective on these things. You see, the Cenozoic, the age of mammals, was permeated by a long-term cooling trend in the northern hemispheres and the higher latitudes in general. And that led to increased seasonality, increased aridity, and of course cooler temperatures. And that resulted in a massive shift from tropical floras towards more temperate floras. So after the early Eocene hypothermal events, we see the retreat of tropical floras into the tropics. They are replaced by temperate woodlands in North America, and then we see towards the Oligocene and the early Miocene the radiation of grassland habitats. So what we wanted to do is link mandibular morphology and disparity to the floral changes that occurred. Could we provide a definitive quantitative link there? So why choose mandibles? Well, because they're quite functionally specific. They are relatively unconstrained by neurosensory structures, as the cranium is, and therefore they are devoted almost entirely to feeding, so mastication and ingestion of foodstuffs. And basically you can see, this has long been known, that you can see these changes and differences in diet from the mandible. So if you look over here, you can see this one here is a browser, so the browsing horse for Rachytherium, and if you compare that to Neohipparion, which is a grazing horse from much later in the Miocene, you can see some big differences there. This one is much more gracile, a thinner corpus over here, much reduced mandibular width, and a small diastema over here. Compare that to Neohipparion, massive mandibular width, large corpus to house those hypsodont teeth, and a large diastema. And that reflects the differences in their diets. You can see that this one over here is obviously has not as large muscle attachment areas as this one, and that's because they're chewing and eating different things. Soft vegetation versus tough, gritty vegetation. So we decided to focus on the perissodactyls. They are hindgut fermenters, they don't chew the cud, so they show increased mastication because all of the majority of the physical processing must happen at the point of ingestion. Furthermore, we decided to look at canids. Why look at canids? Well, we thought, why not? We thought, why not see if we could identify any links in the canids and link those, if we could identify any changes in morphology in the canid mandibles and link those to our herbivores and the flora. So images were collected from textbooks, online museum archives, and of course photos from Christine Janis's own collection of photos of ungulates from her many travels around North American museums. They were guidelined using ImageJ, and that was mainly to pin down this landmark over here on the mandibular angle. We wanted to get the most width whilst also best capturing the shape. Landmarks were put in TPS dig, and most of our analyses were run in either R or PAST. So basically our landmarks were chosen to capture these muscle attachment areas. So these ones over here capture the masseter, these ones the temporalis, these ones over here capture the depth of the corpus and perhaps hypsodonty, and then these ones the symphysis and the see if we can identify the cropping jaws of grazers. So these are our first results, and as you can see here, these are plots through time. So Rogerian in the early, middle Eocene, just after the hypothermals, and here in the Blanken, our final time zone in the Pliocene. And as you can see, there's a big shift right here at the Cadronian, where it sort of jumps downwards and shifts over to the left. And what that is the loss of the browsing taxa, a lot of tapiromorphs, so these guys over here, and of course some brontotheres, and then it's also the arrival of the equids and the rhinos. So there's the shift right there. So, getting down to the family level results, you can see here that horses, which have long been known as the poster boys of the change and transition from browsing to grazing, and that is actually illustrated right here. It's a nice transition towards the bottom left, and that is going from browsing taxa to grazing taxa. So if we compare that to our next big group of Perissodactyls, the brontotheres, you can see that they are also showing a shift downwards and also slightly to the left. Not as far as the horses, but still quite a significant shift, considering these guys are thought of as mainly typical browsers. And indeed, they are starting to show a shift towards the end of their time range towards becoming, say, more mixed feeders, and that's what we're thinking there. Now take a look at this space here. That's the last brontotheres. Compare that with the earliest rhinos. It's a bit difficult to see on this one, I can appreciate that, but they're just here, and that space can suggest perhaps some competition there between brontotheres and rhinos, and perhaps a valid intrinsic pressure on the brontotheres. So the rhinos in general, it's difficult to see any real pattern there. They're very conservative. They don't change their niche, their morphospace occupation. They seem to just stay and occupy that same space throughout their time, and that's despite some big changes in their dental morphologies. Additionally, we also identified niche morphospace conservatism in canids, although we did see some shifts in the Miocene towards the right, and that is associated with the Borophagids. So this cluster here, Borophagines, sorry, and these are the bone-crushing canids, and that really becomes prevalent over here in the Middle Miocene. And then we see it shift all the way back again over here to the left, and that's the loss of the Borophagids and the arrival of Canis. So we did MP Manova test to see if we could identify any significant transitions, and surprise, surprise, the Duchenian Shadronian transition comes up. So that, if you remember, it was our loss of browsers and arrival of the first sort of horses and rhinos. Additionally, we also found the Clarendonian and the Hempilian, and that reflects perhaps a loss of the Middle Miocene browsers, because at that point we see a big morphospace occupation in our horses and also our rhinos, and we're thinking that maybe it might be linked to the abundance of Middle Miocene browsers. Furthermore, we also see the same significance at the Duchenian and the Shadronian in the brontotheres, and that's a strengthening of the symphysis, which I'll talk about later. And also in the Canidae, we see the Hempilian to the Blanken, and that again reflects the loss of the Borophagids and the arrival of Canis. So we did linear regressions against floral data collected from Stromberg 2005 and Stromberg and McInnery 2011. This was phytolith abundance data from 99 sites in North America through most of our time zones, and we found only really just barely significant correlations there between palms, closed habitat grasses, and our disparity. So that would suggest something there, but more data is probably needed to verify this. But nothing was found for correlations with grasslands, so puoid and packard grasses. So that would suggest that grasses are having very changes in flora, apart from maybe this decline in the forest habitats in the late Eocene. But apart from that, we're not really finding any correlations or any links there. So these are our thin plate splines from these significant transitions. So this is the Duchenian and to the what was it? Sorry, let me go back. Yes, Duchenian to the Chadronian. And as you can see, there's growth here of the coronoid process in the Perissodactyls as a whole, and in the brontophis specifically as the symphysis. So that suggests that they're increasing and developing their temporalis muscle, and over here in the brontotheres suggests that they're perhaps becoming more mixed feeders. They're getting more sort of stripping vegetation, strengthening off the front of the jaw. Now here in the Clarendonian to the Hempilian, we're seeing strengthening of the condyle. So we're thinking that might relate to perhaps the repositioning of the jaw as grazing develops in these taxa. Additionally, there are other key transitions in these thin plate splines. We can see regular growth of the molar row and the corpus in the horses and the rhinos. And surprisingly enough, we only see intense pulses of development of the mandibular width and the mandibular angle. And that suggests that once they really developed that, they sort of, they stuck with it, and much of it, more development was focused on the corpus, which might have something to do with the evolution of hypsodonty. In the canids, we see expansion of the tooth row posterior, so that's around the premolar, so we're thinking that might link into the development of the carnassial, and that tooth is very related to sort of shearing function, and we're thinking maybe that could relate to changes towards bone crushing in the borophagids, and also maybe hypercarnivory. And additionally, we see strengthening of the symphysis in the later canid, the canis, I should say, perhaps reflecting a change in hunting patterns. So conclusions, our results on disparity seem to concur with diversity, and it would show that there was disparity declined as well as diversity declined in the late Eocene. Our regressions show some links between the retreat of forests and our disparity, but more data is needed to verify this. As I've said before, grasslands and the radiation of grasslands appear to have little effect on peristactal disparity, and here's just a recap of what we found in our morphospace plots. So specialization in brontothes towards the end of their range, browsing to grazing shift quantified in the equids, and of course niche conservatism in the canids and the rhinos. And indeed many of our results have actually given quantifiable data to many traditional assumptions. I mean, you can't just take these things for granted nowadays. If you want to make new hypotheses on these, you need data for them, and that's what we've done here. So there's future study where we're going to take this, hopefully get more data, perhaps extend it to the artiodactyls and Proboscidea, and of course maybe into South America. South American ungulates have recently been recovered as a sister group to Proboscidactyls, so perhaps it would be interesting to see the transitions of these two groups under very different circumstances. And of course, this methodology is not limited to the Cenozoic. It can be applied to many other time zones throughout the history of life on Earth. Perhaps another floral transition, the angiosperm radiation in the late Cretaceous, the Cretaceous terrestrial revolution. But with all of Earth history available to us, there's a lot of choice to choose from. So thank you very much, and any questions?